Hello and welcome back to another tutorial for the 2D Action Platformer kit. Today, we're diving into the kit's input system, which utilizes Unity's new input system to provide you with versatile control configurations tailored to your gameplay needs. To get started, navigate to the input folder in your project directory where you'll find the configuration file for the input system. Simply double-click this file and a configuration window will pop up. This window is divided into three main sections that we'll explore today. First up, we have the Action Maps section, which organizes input based on different gameplay contexts, essentially different modes like gameplay, menus, etc. Next, the Actions section displays the key configurations for each action within the selected action map. This is where you can define what each button does in various states of the game. Finally, the Action Properties section details the key bindings for the actions, allowing you to assign specific keys or buttons to each action. By understanding and configuring these sections, you can fully customize how input is handled in your game, making it responsive and intuitive no matter what control scheme your players prefer. Continuing with our exploration of the input system in the 2D Action Platformer kit, let's delve into the Player Movement Action Map, an essential component for creating fluid and intuitive player interactions. This action map is specifically designed to handle all player character movements and actions, making it fundamental to the gameplay experience. In the Player Movement Action Map, the basic movement of the actor is managed through the W, A, S, and D keys on the keyboard, and both the analog stick and directional pad on the gamepad provide a seamless and responsive control experience. The jump action is assigned to the space key on the keyboard and the button south on the gamepad, which typically corresponds to the A button on Xbox controllers or the X button on PlayStation controllers. For attacking, the action is bound to the left control key on the keyboard and the button west on the gamepad, which generally refers to the X button on Xbox and the square button on PlayStation. The dash action, an essential maneuver for dodging or covering distances quickly, is mapped to the Y key on the keyboard and button east on the gamepad, often the B button on Xbox or circle on PlayStation. Switching between weapons is intuitive as well, linked to the Q and E keys on the keyboard and the left and right triggers on the gamepad. This setup allows for quick adjustments in combat strategies without interrupting the flow of movement. Access to the in-game menu is crucial for gameplay adjustments or pausing the action. This is handled by binding the escape key on the keyboard and the start button on the gamepad, ensuring that players can easily access menu options at any point. One of the standout features of Unity's new input system utilized here is the ability to switch between action maps on the fly. This flexibility is particularly useful in different gameplay contexts. For instance, when the player opens the in-game menu while in a stage, the Enter menu action can trigger a switch to the Pause menu action map. This transition simultaneously deactivates the Player Movement action map, ensuring that the player character remains stationary during menu navigation, enhancing both usability and game immersion. Lastly, the Button Press Events action map is pivotal outside of stages, primarily within the menus. It manages the confirm and cancel actions, providing a straightforward way to interact with menu options. This ensures that players have a consistent and reliable interface experience, whether they are navigating through game stages or adjusting settings in the menu. To begin adding a new action, simply locate and click the plus icon within the Player Movement Action Map interface. For the purpose of this demonstration, we'll stick with the default name New Action. Once you've named your action, you'll want to define its key bindings. Click on the action and under the Path option, select the desired input type, be it from a gamepad, keyboard, or any other device. After setting up your bindings, make sure to save the configuration to compile the changes. This process seamlessly integrates your new action into the existing map. Now, let's move to the scripting part, which is crucial for the new action to function correctly within your game. When a new action is created, it's not uncommon to encounter an error in the player input system script. This typically happens because the script's interface requires the newly added action to be implemented. To resolve this, you can address the error directly from the Unity editor. Double-click on the error message, which will lead you to the problematic line in the player input script. Right-click the highlighted section of this line and select Quick Actions and Refactorings. From the menu that appears, choose Implement Interface. You'll see a preview showing that this action will add a new function stub based on the action you just created. Once the interface method is implemented, you can find the new function further down in the script. This is where you'll add the specific code that dictates how the game responds when this new action is triggered. Whether it's a special move, an interaction, or any other function, you can code it to enhance your gameplay and provide players with more control options. Inside the Player Input System script, you will find definitions and implementations for all the actions included in the kit. This comprehensive overview not only helps you see how the input system is structured, but also serves as a blueprint for adding new functionalities. For instance, consider the process triggered by pressing the menu button. When this button is pressed, the onEnter menu function is called. The function first checks if the action associated with opening the menu was performed. This is typically done with a condition that evaluates if the respective input event has occurred. If the action is confirmed, a Unity event named onMenu is triggered. This event can be configured to perform various tasks, such as pausing the game, bringing up the menu UI, or other related actions that should occur when the menu is accessed. Following the trigger of the onMenu event, the function then enables the pause menu action map. This is a crucial step, as it shifts the input controls from the standard gameplay controls to those specifically designed for menu navigation, ensuring that players can interact with the menu without unintended gameplay actions. Simultaneously, the function deactivates the player movement action map to prevent any player movement during menu navigation, ensuring that the game state is appropriate for menu interactions. These actions and their interactions are typically managed and configured within the player character prefab. By modifying the player character prefab, you can easily add new actions or customize existing ones, enhancing how players interact with your game. This setup allows for a high degree of customization and scalability, enabling you to tailor input handling to the specific needs of your game and its audience. Wrapping up our look into the input system of the 2D action platformer kit, let's delve into enabling and customizing touch inputs for mobile devices, an essential feature for today's mobile gaming market. To get started, navigate to the Player UI prefab located within your player character's configuration in the Unity editor. Here, you will find the on-screen buttons game object. Activating this object is straightforward. Simply select it and enable its visibility in the UI frame. This makes the touch controls visible and interactive within the game's user interface, providing a mobile-friendly control scheme. The on-screen buttons game object includes a virtual joystick and buttons that correspond to essential actions like jump, attack, dash, and accessing the menu. These controls are designed to offer a tactile, responsive input method for mobile gamers, replicating the functionality of traditional keyboard or gamepad controls. To tailor these controls to fit your specific game mechanics or preferences, you can modify the key bindings directly within the Unity inspector. Each button within the on-screen buttons can be configured by setting the control path in the inspector to match the desired inputs. This means you can easily assign each touch button to trigger any action defined in your game's input system. This configurability ensures that your game can offer an optimal user experience across various devices, including smartphones and tablets, by providing a control scheme that is both intuitive and adaptable to touch inputs. With this setup, you're now equipped to extend the reach of your game to a wider audience by supporting mobile platforms, thus enhancing accessibility and potentially increasing your game's user base. And this wraps up the tutorial on the input system for the 2D action platformer kit. We've covered everything from setting up basic controls to customizing actions and integrating touch inputs for mobile gaming. I hope this walkthrough has been informative and helps you enhance your game's interactivity and player engagement. If any part of this tutorial was unclear, or if you have any questions, don't hesitate to reach out. You can leave a message here or join the conversation over on the official Discord server, where I'm available to address all your questions. You'll find the link to the Discord server in the video description below. Thank you so much for watching, and if you're interested in staying updated with the kit or other future projects, please consider subscribing. Happy developing, and I look forward to seeing what amazing games you create with the 2D action platformer kit.